So good evening, everyone. Let us just wait for 2-3 minutes so others can join. Okay, we can start then. So good evening, everyone. My name is MIG Rakesh. I am a doctoral student at IIT Bombay. So working in like certification area. So I am one of the TA for this manufacturing process casting and joining course. So this was like the last interaction session. So in this session I will be giving some tips or solving some numericals or some problems so that it will be helpful for you in solving this assignment. So without any further ado, I will start the class. So just to quick recap, so in this week, so the professors taught different types of welding processes, starting with simple processes, then going to the advanced processes like laser beam welding, plasma arc welding, such types, friction welding, resistance welding, and gas welding, as well as the solid state welding and some of the solid state welding processes also. Then coming to the characteristics of arc welding, so in which we will be you guys will be given introduction to some concepts of this voltage and current characteristics during this welding process, and how these vary with different types of processor parameters. Say different power I am giving, how the velocity of the voltage is varying, and what type of power I need to keep. So different types of aspects we will be learning in this, as well as there will be some small numericals also regarding this topic. Then coming to the other part, that is fusion welding types such as shielded metal arc welding, metal inert gas welding, and tungsten inert gas welding. So in which the fusion is happening, we can use either we can use a consumable electrode or non-consumable electrode, or else we can use filler material or without filler material. So different types of types of process we have been exposed to. Then coming to gas welding, and what are the different types of like flames or different types of gas weldings, and what are the ratio of gas to air ratio, or such types of small things we have been discussed. Then coming to, if there is no chance of welding two metals, then we will go to this brazing and soldering. So soldering, you guys I think well known, which is widely used in this designing circuits or small electronic components. Then coming to the brazing, then finally it was ended with defects in the welding. So sort of inclusions, slag inclusions, insufficient filling, pipe defect, penetration defect, such types, different types of welding. And main thing to avoid this, to like keep the welding surface clean, preheat the surfaces, and use correct combination of electrode and flux material according to the weld joint. These are the some of the things. And you can use some shielding so that the oxides or any gas entrapment in the weld pool will be reduced. These are the topics that was I can say briefly discussed in the topics, and there is much more to learn in if you guys refer any standard textbook. So this is like a very quick recap. So I'll be solving some of the numericals. Sorry, not the numericals. Most of the part is theoretical here. So we need to use the memory based. So most of the questions are like memory based. So once you understand the process, it will be very easy to solve these questions. So those guys, those students who are attending, they might know. So in this session, I would like to you guys answer the questions. So I will wait for 1-2 minutes so that you can read the question, you can read the options, and you can just reply in the chat box. I can see, so that it will be very interactive both the ways, and we can clear the doubts very efficiently. So this was the question I am keeping. So the size of heat affected zone in welding increases with. The first option is decreased welding speed. These are the options. Decreased welding speed, increase in base metal thickness, increased thermal conductivity of base metal, higher input rate process, increased hardness of the metal to weld. So already there was one answer. Okay, nice. So what happens, so we have to read like what happens to the parameters if my heat affected zone is increasing. Only 2 options I got, sorry, 2 responses. So I'll just give some brief introduction to heat affected zone. So when we do simply, if you take two joints, simply lap joint you can say, and you are performing welding operations. So if you take the cross sections, you might know there are some 4 categories. One is the fusion zone, then the interface, weld metal interface, then heat affected zone, and unaffected heat zone, parent material you can say. So one is the heat affected zone is very important, in which maybe the failure might occur because of some microstructural changes, say some the grains are enlarged, coarse, and next to that it will be finer. So this is all related to the sort of heat transfer between the weld pool and the surrounding metal, say. So if that heat affected zone is to increase, so what we should do, like what happens? I think no answers yet, so fine. So only 2 answers I got, which is it is the correct option D, which is the first and third options. So if you see, so heat affected zone, first option is decreased weld. So these type of questions, it will be easy if you strike off the unnecessary one. So decreased welding speed. So if you decrease welding speed, so you are staying at the same spot for longer time. So there is a chances of giving high input, or chances of getting more input to the workpiece. So we are not mentioned that what is the heat input we are giving, but in common, if the welding speed is decreased, we are compared to the fast welding speed, we can get more heat input, so that more heat affected zone will be there forming. So that is the correct option. So if we can strike off all other, so only B and D is the remaining. So next is we can directly go to third option, higher input rate process. So in higher input rate process, if you see heat input, so we have, so how much energy you are keeping for a small mm², so small unit of area you can say. So I can take 2 types of welding process. One is gas welding, and I can say laser welding I can take. So in gas welding, the heat input rate is lower because it has a wider spread, but in laser welding, the heat input rate is much higher, so that very high input rate will be there at a small area, so that it will be done very fast. So the spread is very less compared to the other process in which the spread is very high. So this is one of the reason why high input rate process is required. This high input rate, it is relative, it is not too high such that the metal evaporates. It is within the range. So this was the correct option, so we can directly strike off D and we can go. So we can see the other options also as well. So in third option, increase thermal conductivity of the base metal. If thermal conductivity of the base metal is increases, so either there is no melting at all, because all the heat input you are giving is already taken away by the heat transfer to the surroundings. And if you see option 5, increase hardness of the metals to weld, it doesn't matter if the hardness is increased, it is very easy to melt actually. It is not completely related to our heat affected zone topic. So the correct suitable options is 1 and 4, which is option B. So any further clarification required, or is this enough, or any okay, then I'll move to the next question. So it is a bit bigger question. So it is like the same as earlier. We can read the options and we can strike off. We can read the statements given and we can strike off all the things. So first statement is copper is relatively easy metal to weld because its thermal conductivity is high. Oxy-acetylene gas welding is the most widely used oxy-fuel welding process because acetylene mixed with an equal volume of air burns hotter than any other commercially available fuel. Third option is resisting welding process makes use of heat generated by electrical resistance to achieve fusion of the two parts to be joined. No pressure is used in this process and no filler metal is added. Finally, an electric arc is a discharge of current across a gap in an electrical circuit. The arc is sustained in arc welding process by the transfer of molten metal across the gap between the electrode and work. And the fifth statement is metals with high resistivity are generally easier to weld. So what do you guys think the correct option is? Like they are asking what is the right option. So we have one option is A and one option is B. Like one response is B. So any other options apart from option A and B? It will be useful if you guys interact. So just answer this question. So what are the combination of right statements? So we have two responses, only two. Any other response? I will wait for one more minute, then I will answer the The first option, like first statement, you can readily strike it off because I just explained it. If thermal conductivity is too high, so whatever the heat you are giving, it will be easily dissipated. So it is very hard to melt the workpiece, the material that is using. So first option is wrong. But the rest of the options are very closer. Unless you have clear understanding, you cannot answer this. Okay, then I will explain this. So as I said, the first statement is not correct because copper is very highly conductive material. So whatever the heat input you are giving, it is easily radially transferred. So it is, if the conductivity is very high, there is very high chance of heat transfer. So it is very difficult to melt the material. Yeah, sorry for that. So strike directly you can strike off the first option. The second one is this is very like tricky questions. Oxy acetylene welding is most widely used oxy fuel welding process because acetylene mixed with an equilibrium air burns hotter than any other commercially available fuel. It looks like we didn't study at all, not have much clear understanding. So let us keep this away for some time. So let us move to the next one. So we know that first option is wrong. We can directly strike off option B and D. So only option A and C are the correct one. So of course, obviously the option 2 is the correct one. So the next question: resistance welding process make use of heat generated by electrical resistance to achieve fusion of the two parts to be joined. No pressure is used in this process and no filler material is added. So so if you see this statement, no pressure is used in this process, you can clearly make out whether it is correct or not. So that is true that we are not using any filler material, but in resistor welding, electrical resistance is used for bonding. Whether it is fusion or solid state, that it's okay. But the correct option is we use some pressure. We used some pressure to hold. So if you remember this spot welding thought, so before giving any electrical power, we firmly hold these things. Then we will apply some pressure. Then this spot will be formed. That weld nugget will be formed inside. So we use some pressure in this process. But here it says there is no pressure is used. So that is one wrong statement that was used. So I can strike off option 3. That is, but still I have to read the other statement. An electrical arc is discharge of current across the gap in an electric circuit. True. The arc is sustained in arc welding process by the transfer of molten metal across the gap. So this was the wrong statement. Why wrong statement? The arc is sustained not because of the transfer of metal, but sustained due to that maintenance of that ionization column. If you see any arc process, that arc you can see. So that arc formation is the what it is making sustained. That arc is like ionized that electric that zone. So there are 3 regions across that, but we don't go deep into it. But it is sustained due to that ionization column that is maintained between the electrode and the workpiece, not because of the transfer of metal from the electrode to the welding weld pool, you can say. So that we can strike off option 4. So the only option we left is option A. And now coming to now I will read the 5th statement. Metals with high resistivity are generally easier to weld. So if I am having high resistivity, so I will just write the formula, then So if you are a high resistivity, it is easier to generate heat and easier to weld. Like in one way to understand this statement. Hence this option is true. I think it is clarified, or you are having any confusion still, you can ask me directly, or you can type in the chat box. So here I mentioned resistivity, but that is fine, I guess. So R resistance is equal to rho L by A, in which rho is the resistivity. L is the length and A is the area. So remember this formula, R is equal to rho L by A. It is useful in some numericals too. So what happens if the area increases, so that resistance will decrease, so that electricity can easily pass. Why? Because the cross section area available for electricity to pass is increasing, so the resistance will decrease. Of course the electricity passes only on the surface, but still it is increasing. No need to bother if you don't understand this formula, that is fine. Okay, then we can move the next question. Okay, so in electrical arc discharge, what is happening? The statement is saying that the arc is sustained. So there is one doubt regarding this. So the arc is sustained in arc welding process by the transfer of molten metal across the gas between the electrode and workpiece. So what happens? So if you use a consumer electrode, so in which the electrode is melting and you are continuously feeding it, so that electrode is melting and dropping in the weld pool, and that is how it is going on. But that is not the thing that is keeping the arc sustained. Sustained in the sense keeping the process without any interrupts. So what is it keeping interest is that so between that workpiece and the electrode, so there will be small gap, say for 3 mm or 4 mm gap. In that gap, if you see, there will be very high reflective thing that you see while doing any welding process. So what exactly happening is that there is changing of electrons from electrode to workpiece based upon what type of polarity you are using, or workpiece to electrode. So that it forms a column basically. So it's an ionized column, which is very which falls under the visible spectrum. That is why you are seeing it. So that is what responsible for keeping that arc constant. So if you move away, so that column will disappear and the arc will be gone. But if you move very closer also, it is problem. So there will be an optimum distance in which you have to keep to maintain that ionization column. So that is what keeping the arc sustained, not the metal that is melting and dropping down. I hope you understand. Okay, thanks. So if you want to study more about this column, what is happening between that 3 mm gap, so you can read this any standard book, so in which with the distance in y-axis, and what happens, there will be anode potential, electrode potential, and cathode potential. So that gaps we can see. So that is what that column is made of. It's interesting topic to see also. Okay, we can move to the next question. So each question is testing some different aspect of welding. Only you can answer only if you know most of the things. So this is completely related to ultrasonic welding process. So in ultrasonic welding process, the oscillating shear stresses of ultrasonic frequency are applied to the interface of the two metals to be joined. So why it is being applied? The first option is to raise the temperature at the interface of the two parts to be welded. Second option is to break down any surface films to allow intimate contact and strong metallurgical bonding between surface. And option C is to improve the physical and metallurgical properties of the welded joints. And option D is to melt the interface of the two parts to be joined. So I want to remind, this is not the fusion process, ultrasonic welding. We generally categorize this into solid state welding, in which there is no liquid phase. So keeping that in mind, you can answer this easily. Nice, nice. Okay. So most of the are you guys correct? That is option B is the correct one. So any other options you guys think correct? Nice. Very good response for this third question. So there is one question, one answer, option A. Okay, we'll keep it. Option A also one. Some change their mind, I think. Option C. So A, B, C. Nice. It is good to see all the options, but there is only one correct option. So the question is, in ultrasonic welding process, oscillatory shear stress of the ultrasonic frequency are applied to the interface of two metals to be joined to raise the temperature, to break down any surface films and make a good bonding, to improve the physical and metallurgical properties of the weld joints, to melt the interface of the two parts to be joined. So we can directly remove option D, because we are not melting anything. It is just bonded plastic. So there is no exact melting happening in this. So D we can remove. So only ABC we have to select. To raise the temperature at the interface of the two parts to be welded. That is not actually why we apply for this ultrasonic welding. We doesn't bother about temperature, since it is happening due to solid state welding. We doesn't bother about temperature. Of course, it will be less than melting temperature. It is to some extent option A also is correct, but not the appropriate thing. Like, it is not the most appropriate. It is true. Of course, if you apply any ultrasonic pressure, we are increasing the temperature, but that is not the goal. I am using that ultrasonic process for that. My goal is to join the two surfaces. So I can neglect option A if I read the other options. Option C is to improve the physical and metallurgical properties of the welded joint. It happens once you made a bond. Without making any welding joint, you cannot assess the metallurgical properties or things. So option C is wrong. We apply these ultrasonic frequencies, that oscillating shear force, to join. not to improve the physical and metallurgical for the welded joints. So we are left with option A and option B, which are option A is like what is this is the one of the byproduct you can say, but option B is the correct option. Most of you guess the correct one. It is so if there is any surface element, it will be broken down, and there is plastic deformation happening between the surfaces, and finally it result in interlocking and a good strong metallurgical bonding between two surfaces. So there was very nice video also explaining this thing. So we take so if you see any batteries in which the parallel plates are there, aluminum or any plates, so we just apply some pressure and we give this ultrasonic pressure frequency, so that the surface films will be broken down and there will be a strong metallurgical bonding between the surfaces. So option B is most appropriate. So if I want to select about this, B is one you have to select. Any doubts? Okay, I think it is clear for everyone. So I'll move to next question. So this is like most of the questions are theory based, so most of the like statements and select the correct option. So in arc welding, the voltage decreased sharply as the current increased till 50 amps, because until 50 amps what is happening? So the arc dissipates more heat since its radius increasing and the shape remains cylindrical. The resistance to current flow decreases since the conductivity increases. The arc bulges out and the resistance to current flow decreases. The arc dissipates less heat since its radius increases and shape remains cylindrical. The arc bulges out and the resistance to current flow increases. So which option you think the correct one? Okay. So some says option 1, option C, then option B. Option A. Okay, option B, one more. Okay, I will not give the answer right away. I will remove some options. So if you read the last statement in the question, so there is one more. See. So until 50 amps of current. So this is all the options are related to what happening before 50 amps. So I can directly, by looking at the statements, so there is arc bulges out. So this happens only after 50 amps. So I can right away strike off option statement 3. So that removes option B. There is one more option. So those who answered B, you can reconsider now. Okay, I think there is some confusion. I will give one more minute. All the options are, I think, people, you answered all the options. There is one vote for option D also. Remember, I have mentioned this formula: resistance is equal to resistivity into length in length by area. This is what we can apply in this. Okay, then I will explain. So option 2 or 1 are statement. If one statement is true, I can strike off the other. So option statement 1: the arc dissipates more heat since its radius increases and the shape remains cylindrical. And second option is the resistance to current flow decreases since the conductivity increases. The fourth option is the arc dissipates less heat since its radius increases and the shape remains cylindrical. The fifth one is the arc bulges out and the resistance to current flow increases. So I can directly strike off this option also. There is arc bulging. So option D is wrong. Because the arc bulging happens after 50 amps, not before. We are left with if only option 1 and 2. Okay. The resistance to, so if you see statement 2, the resistance to current flow decreases since the conductivity increases. Which is a true statement, right? If the conductivity to increase, the resistance should be lowered, right? So option like statement 2 is true, but it is there in option A and C also. So you have to prove, you have to see option statement 1 and statement 4. If any which is wrong, then you can answer this. So if you see option statement 1, the arc dissipates more heat since its radius increases and the shape remains cylindrical. So if you remember in casting this volume to area ratio, so if the radius is increasing, what happens to volume to area ratio? Increase, decrease, same. So same concept you can apply here. So if I take volume to area I am taking here is the surface area, of course. So volume to area ratio, if radius is increasing, what happens to this volume to area ratio? Increases, decreases, or same? Can anyone answer? Considering its side is cylindrical cylinder, take a cylinder with radius r, and height also you take as h is equal to r in our case, for simplicity you can say. So what happens to volume to area ratio if my radius is increasing? Okay, increases, correct. Any other answers? Okay, only one answer, increases. So you can say, yeah, here I'm taking surface area. So in a cylinder we have, so top side pi by 4 d square, bottom side pi by 4 d square, and the lateral, so pi dh is the denominator. In the numerator we have pi by 4 d square into h, or pi r square h. So what happens if I increase the radius? So in my case, I have pi r square h on the numerator. In the denominator I have 2 pi r square plus okay, pi r square h is the volume, and this is the surface area. I hope you can see everything. So if in this case, if I increase radius, what happens with the whole term? It obviously increases, right? If you want to clearly understand, take some values r, h, and you can see this is simple. So if b by a is increasing, what is so if v by a is increasing, so what is happening? My heat transfer is increasing or decreasing? So let me understand in this way. So in riser design, if you remember, so I should have more V by A ratio. So what does it mean? That heat content in the riser should be more, so that the surface area is decreasing, so that my heat transfer is less. I think you, if you remember. So what if V by A is increasing with increase in radius, so the heat transfer is reducing, because the surface area is in denominator, which is reducing. So that is why that ratio is increasing, V by A. In that way you can understand. But in the option 1, if you see, the arc dissipates more heat with increase in radius, which is false, because with increase in radius my heat content is increasing, irrespective of the surface area also increasing. So my heat transfer is decreasing actually. So option 1 I can strike off. So only the right options remaining is 2 and 4. Option C is the right one. Option 2 is correct, and option 4 also correct. The arc displays less heat since its area is increasing and the shape remains cylindrical. You can answer by this last statement also. The shape remains cylindrical. Before until 50 amps, the shape remains cylindrical. Once it crosses, it bulges out. This is what experimentally people observed. Once it bulges, so the resistance will increase, the conductivity reduces. So in order to increase, so the current is increasing, but the voltage is not increasing much, but it's increasing slow, in a slow rate, slow manner. Did you understand this V by A concept? Is it clear, or any confusion you are having? Yeah, thanks. So I'm just relating two concepts, V by A in casting as well as welding, so that it will be easier to understand. Okay, we'll move to the next question. Like sort of final question. So for welding sheet metals using arc welding, this is completely like concept based as well as memory based. So what happens? What type of polarity? I mentioned earlier polarity. So what type of polarity I should use for welding sheet metals? Straight polarity or reverse polarity or alternating? So option A is polarity of workpiece is made negative and direct current is used. Option B is polarity of workpiece is negative and AC current is used. Option C is workpiece is positive and AC current. Option D is workpiece is positive and DC current. So what type of polarity I have to use for welding sheet metals? So sheet metals, it should come to your mind that the thickness is very less. If I remember, it is very less than some 5 mm, say 5 or 2.5 mm, less than 2.5 mm. So thickness is very less. So if I use, so I have to use correct polarity, otherwise it will melt through. So I cannot get a welding in it. Rather, I'll get a hole cutting in it. So there was one answer for option 1. Okay. So 2 for option B. Okay, one option. So they're equal. Okay, B. So let me put in this way. So if I use a straight polarity, so here nothing is mentioned, but in convention we say straight or reverse polarity. So in these two cases, depth of penetration is what we have to understand to answer this question. So okay. See, so I just answer this one. So in which polarity we'll get more depth of penetration, a straight one or a reverse one? So more depth of penetration in 1 or 2. Reverse polarity we get more depth of penetration, or the straight one. Okay, so let me so if you remember the passing of electron clouds, so from negative to positive they are more, this the affinity is more from negative to positive rather than from positive to negative. So if I take a workpiece, and if I take an electrode, so if I keep electrode negative and workpiece positive, so the electrons come from negative pole, negative, and they hit the positive one. Okay, and if I reverse it, there will be reverse also. From positive also there will be some electrons which are hitting the electrode, but the more electrons will come from negative one rather than positive. So that in straight polarity in which the electrode is negative and the workpiece is positive, we will get more depth of penetration, since we are having more electrons colliding the workpiece compared to the electrons which are colliding the electrode. Okay, so I'll put it in a conventional way where people use. So in straight polarity we generally use direct current and electrode negative, so in which we will get a very high depth of penetration, whereas in reverse polarity we use direct current, electrode positive, in which we will get very high spread, not the depth of penetration, very less. Why this is happening? Because the electrode polarity affinity from negative to positive is more compared to from positive to negative. That is one you can say. So this is what if you heard of this unconventional process, this electric discharge machining, that is this straight polarity is what we use. For removing material on the workpiece. Okay, so now coming to, this is what the theory behind. Now coming to the question. So first option, like, so we can cancel out option C and option D because no one answered. So the question, correct answer lies between A and B. So if I say take option A, polarity of the workpiece is made negative and the direct current is used. Correct, direct current is used, not the AC. So I can strike off B option also. So if you say, if I didn't mention AC, so AC will be between these two, reverse alternative current, we can say that one. So for welding sheets, these are very thin, so that I need direct current, electrode positive, so that workpiece should be negative. So the option A is like workpiece is made negative and direct current is used. So that is what the correct option. So that my depth of penetration is less, but I can melt some good amount of material on the top itself to make a that strong bond between the two plates or sheets. I hope it is clear. Any doubts? Thanks. I think this was the last interaction session and the classes are almost over. Assignment, you can attempt assignment after the Monday session and you can wrap it up and prepare for the complete portion. So there are not much, no, I can say no numericals or very less numericals in welding compared to casting. In casting there are very good number of numericals. So in welding more theoretical questions will come, so you need to concentrate on those. So any other doubt you are having regarding these topics?
Sir, please show that question number first.
Question number?
First.
Okay. Yeah.
Okay, sir.
Yeah. So if you have any doubts, you can stay and ask. Others, you can leave. And thanks for attending, and thanks for your patience, and all the best for your exam. Thank you.
Thank you, sir.
Yeah. Yeah, thank you. If you have no doubts, we can close the session, and all the best.
Thank you, sir. Good evening, sir.
Yeah, so only 5 questions I have explained. So there are more questions so 5 more questions which will be helpful for your assignments, that will be solved in next Monday session. So in order to avoid this repetition, so we have divided the questions and explained.